Okay, so this is basically about the molecular orbital. So we need to first draw the molecular orbital of the Cn plus. As you can see, I already drew it here. I will just list through how to draw that. So as you can see, for carbon and nitrogen, they are all in period 2. So they all have 1s, 2s, 2p orbitals. So we're gonna construct the molecular orbital based on them, right? So you will use carbon 1s and nitrogen 1s to construct a sigma 1s bond and sigma 1s antibond. And same for the 2s. And for 2p, right? 1 2p orbital will be used to construct the sigma 2p bonds and sigma 2p star bonds. And two 2p orbital from each atom will construct the pi bond and pi star antibond. And then we need to start fill the electrons. So for carbon, electron configuration is 1s2, 2s2, and 2p2. So the carbon has 6 electrons. For the nitrogen, it has 1s2, 2s2, and 2p3. So it has 7 electrons. And we notice that the Cn plus has a positive charge. That means we need to minus 1. So in this case, it becomes 12 electrons. So we can start filling the electrons here. So I try to fill it myself, but maybe I'm wrong here. So let's redo that again. So for example, when we fill the electrons, we start filling them from the lowest energy state. So we start fill 1 electron, 2 electron, 3 electron, 4 electron, 5, 6, 7, 8, 9, 10. And it turns out, right, there are another 2 electrons. So that will fill here 11 and 12. So now we can try to answer some questions here. You'll find that antibond. So when you have star, right, it's antibond. You have 1, 2, 3, 4. You have 4 electrons in the antibonding orbital. And for the bonding, you have 1, 2, 3, 4, 5, 6, 7, 8. So in this case, you have 8 electrons in the bonding orbital. So the bond order equals to the electron in the bonding orbital minus electron in the antibonding orbital over 2. That's equal to 2. So this is the bond order. And the final question, does this compound exhibit magnetic properties? The answer is yes. Why? Because look at here. It has single electrons, single unpaired electrons at this pi orbital, right? Which means it's paramagnetic. So this is the answer.